Hey guys, how's everything going? This is JSer. In this video, I'm going to solve another problem from BFE.dev. It's 137. I just solved the problems top down, so this one should be 137. Okay, traverse binary tree vertically from left to right, from top to bottom. The binary tree contains positive integers and node values. So this is binary tree. We would go from left to right. So first one is 6, and second one is 4, and then 2, 7, 1, 9, 10. And 1, 9, 10 actually has the same position, just as 2 and 7. 1, 9, 10 have the same position, and they should be ordered from top to bottom, right? Yeah, from left to right, and then from top to bottom. And 3, 8 is 5. If two nodes are at the same position, their order should inherit from their parent node. For example, 9 and 10 are at the same position. Since 7 is before 8, so 9 should be before 10. Okay. Yeah. Okay, let's take a look. So if they're for this tree problems, we just think about the basic case. If there's only one node, we would just return 1, right? If it is the 1, 2, we would be 2, 1. And then if there is 1, 2, 3, and we just have 2, 1, 3. If it is 4, we have 4, 2, 1, 3. And for 5, we have 4, 2, 1, 3, 5. And then we have 6, right? So 6, 4, 2, 1, 3, 5. And then we have 7. 7 should be 6, 4, 2, 7, 1, 3, 5. Actually, we could think of something, relatively to the root node, right? If we think about the root node is 0, here 0. The first one is, so for the first array, for the basic case is 1. And then 2 actually the relative index is from 0 is -1, right? So we kind of insert an element in a -1 here. So insert 2 here, and then we get 3. We should keep the order, right? First in, if the parent is first, then its children should be first. So 4 before 5, and 7, 9 should be before 8 and 10. So we should traverse the way with, I would say, wait a minute, in order, pre-order, in order, pre-order. This is pre-order, right? Pre-order traversal. Pre-order, in order. Pre-order, it means the root is in the first element. In order means, this is pre-order traversal. We first traverse through the root, and then left and right. Right? So 1, 2, and then we go to 4. We set the 4 to the -2, right? The index is -2. Okay, so set the root to index 0, then would be, okay, like this, right? And then we got 2. So it should be -1, 2, 0, 1. And here should be 0, -2, 4, -1, 2, 0, 1. So we use a pre-order traversal, pre-order tree traversal, and to keep the data collection like this, we couldn't use it. We cannot use array, right? Or we could use a proxy here. If we use a proxy here, no, all the index actually will be shifted, Yeah, it's not okay. We should need to use a map. So use map. The number should the index, right? The first one is the index in number, and then the elements we use array to hold the elements. Array of integer, right? Okay, number. Yeah, we use it hold the data. And so at last we would get the some data like this, but we need to transform it into an array, right? In an array, we need to get to know what's the how should I say left one? What's the length of the left one? So keep track of the minimum index. And then at last we would suppose that it's negative x, right? And then we would traverse through the map. And the internal logic of the map in JavaScript, I think it should be something like linked list, ordered map. So there will be a linked list. So for the traversal, it should be linear time traverse through the map, and then okay. But when we initialized, okay, the index and the maximum, right? Maximum. Okay, I have to say mean and maximum. So the length, right, would be minimum of the 0, -1, -2, -3. So there should be say -3, 1, 2, 3, 1, 2, negative mean plus max plus 1, right? And then we initialize array of length, traverse to the map, and set the item. Yeah, that's it. So this is our approach. I would say it's it should be okay. Let's take a look at the time and space complexity. Pre-order traversal. Let's say there is an n node, so it's obviously n big O n. Map to hold the data for each index, and the worst case is that every node has a new index, so it's linear space. Keep track of the minimum. This is constant, and get traverse through the linear time and set the data. Yeah, so this is the approach. Let's get to it. Okay, so let's first create the map. Okay, map. I would say, yeah, you just use map, new map. Okay, so we create, as we usually do, we create a walk method, which walk on a node. Well, while walk on this node, we should have an index attached to it. Default should be 0. Okay, for the root, default is 0. And then what we do, we step on, supposedly little man, stepping on this node. And what we do, we collect the node to the map, right? So if map has node, no, not the node index. Oh, if it has, then it should be array, right? So get the index and then push node value. It says value, value, yeah. If there is no index, no item, we will say set the index with the node value, right? And don't forget, update the min max. Yeah, minimum, we should set it to initialize to infinity. That maximum should be negative infinity. This is a common trick to update the data. Okay, minimum should be minimum, and the index. Max should be max index. This is it. And after we step on the root node, then we go to the left one, right? If node, okay, we will just set the if here. If node is null, we just return. We do nothing. Okay, and then we walk on the left, walk on the node left, walk on the node right. So this is it. We traverse through all the nodes, we get the map, and then we have the minimum and the maximum. So the length would be minimum plus max plus 1. Const result would be new array length. Now for const, which is the index and which is the value of this is the map entries. The index is the raw index, I would say raw index. The raw index, yeah. Okay, all the index should be shifted to the right, right? 0 go to the negative min. If there's -1, then this should be 1, this should be 0. So our target goal is to set the leftmost index to 0. So the results, the right index should be raw index negative minimum set to the value. We don't do sort here. Yeah, we don't do sort here. We already had the index. We could just do it with linear time. Okay, and then finally we just return the result. I think you should. Oh, I see. Oh, I forgot to. I need to flatten it, right? Yeah. After we set the right order, we use the flat. Wow, this is cool. It's not easy to recreate by manually for this kind of node structure. I'll just submit it. Let's just review one more time to see, if we get it right. Okay, actually, I've already find the problem here. We just defined a walk, but we didn't walk route. Let's take a look at this code once more time before we submit. Create a map, get the min max. This is a walk method. We walk it, and then get the length, and then create the result. We update the index, and then we flat it. Okay, walk. Okay, if it has it, we push. Because it's array, so we push it. If not, we create a new array to hold that value, and then we update the minimum and maximum. Go to left, go to right. I think this should work. No. What? Oh, what's the problem? For 1, 2, 3, this case, we expect 2, 1, 3, but we get 1, 2, 3. What? Really? Okay, where is the problem? We walk the route, right? This is the route, and then shit, I forgot to update the index. Go to left, we -1 plus 1. Sorry, this is a mistake. Okay, this is right. Example case is right, but C spec for illustration. Okay. What's this? Something like this. Diff is too big. Ah, what? We have a problem here. We actually return what? We should return 4, 9, 13. 4, 9, 13. We actually get 13, 9, 3. 13, 9. Ah, yeah. This is there is a problem. Because we pre-order traversal, so the 13 becomes before 9, right? Ah, I see. Wow, this is a problem. Okay, so the DFS is actually not working. The general idea should work, I would say. The only problem is that DFS is not working well. Tests no. The assumption that first in, first out is not right about the node order. It's not right. So 13, 10, right? Yeah, because 8 is before. Yeah. We should use BFS, okay? Layer by layer. Okay, we should use BFS. Well, it's not difficult to do BFS. We will just create, as we usually do, we use use a queue, right? We use a queue to hold the root and the index, which is 0. Okay, while this queue is not empty, we get the element out. Actually, we don't need to use the shift. We could use stack push because we only need to do it oh, wait a minute. We need to keep the order from left to right, right? Then we could just push the element. Okay. For shift, we push 2 in and 3 in and shift and get 4 in after this. So we could do this order. If we do the opposite way, we do 1, 3, 2 and 5, blah blah blah. The order is not kept, right? Because we're doing it in the opposite way. It's hard to do. Okay, I'll just keep the natural way, so from left to right. Okay, we shifted the head out. This is the node. And this is the index. And we do the same. Map, okay. If map has index, map get index, we push the node, the value. If not, map set the index with a new array. We update the min max. Max equals max index, and we would if this node has left, we push into the queue, right? Push node with the index -1. If node right, we would queue push node index +1. And so we get 1 at 0, 2 at -1, and 4 at -2. Still, the other logic should just work well. Let's try. It seems that infinite loop. Wait a minute. Root. We shift the element out, and then if left. Ugh. Shit. Not alright. Not right. What? This is the case we're seeing, and we expect 210, 2610, 148. So we get should get 89, but we get 98. 89. Why we get 98? There's something wrong. We've already used the BFS actually. 1, then we get 2, 3, and then we get 4, 5, and then get 6, 7, and then get 8, 9, right? Push 10 in. And we actually get 10, 11. And then we get what? Oh shit, it's not BFS. It's also not BFS. Like here, when 13 gets in. When 13 gets in, when 13 gets in, and 12 actually becomes first. Shit, it's harder than I thought. So the problem becomes at this node, right? We get 10, we get 11. Okay, at this point, the index actually changes. So there's a naive solution here, I would say. While after we push it, we actually could sort the nodes in right order, right? Now JavaScript has the order should be it's stable, so there's no problem of the 10 and 11 here. The problem become 12 and 13. We just sort it. Wow, this is not cool. Still not okay? Oh, no, it's not index, but 0, but 1. Shit. Oh, almost pass, I would say. Okay, now we get 4, 13. Ah, wow, this problem is trickier than I would thought. We need to do it layer by layer. So sort should be my bad. The sort should be done after each level. So I'll push into null. So while it is okay, let's say let head equals q the shift. While wait a minute, we would stop when the null is met. This is the separator. Okay, we initialize a head and we would use a while loop while head is not null, and we would do this and keep processing and inserting, push the node in, and when we met a head, when we meet a null, then we should skip it, and this means the end of a layer, one layer, right? Then we sort. Object null is not iterable. Object null is not iterable. Huh? What is it? Object null is not iterable. Where do we... This one? Head is not null. Ah. Ugh. Yeah, okay. While head is not null, we destructed, and here we get to the next one. So we could actually let head, and while let equals q dot shift, and we destruct the node and index, and then we would if we met a null, we would stop. Okay. Yeah, this is what I want to do. Oh, still not pass. Shit. 2, 6, 10, 5, 8, 9. Now again we get 5, 8, 9. 5. Where's 5? Two, 6, 10. This is actually a different case. Wow. This, okay. 2, 6, 10. 1, 4, 5. 8, 9. We get 9, 8. 1, 4, 5. 8, 9. We actually get... Actually, we've already sorted. 8 should be before 9. 8, negative 8. The index, so A should be before B if it is smaller. If it is same, I remember that JavaScript is stable, I would say. It's not stable? Really? Okay, what's the test case here? Oh! Oh, shit. Oh, nice. do we have this method in the code run? No, it's not defined. Shit. What, this is okay, let's review our code one more. Shit. Okay, if this is a re-interview, I'm gonna actually fail the interviewer. After we push, we need to push separator to identify the end of a layer. Submit. Cannot read property 1 of null. Cannot read property 1 of null? Let head. Oh, I see. Shit. When I sort it, I cannot use this trick as using separator here because null will be used in this sort. I'm stupid. So there's another way of doing this, which is the length actually. Let count equals q to length while count this decrements while it's bigger than 0. We would shift it. We would q.shift. And then we don't push null here. Yeah. Oh my god, this is harder than I thought. It's so... Wow, this is... Wow, this harder than I thought. Needs to attention to what? Okay, this is not... Here is my solution with BFS. Plus map. Okay. This is it. I posted on the discuss panel. Wow, this is very, very interesting. Hope this video helps. And don't forget to subscribe my channel. I will bring more videos to it. And yeah, stay tuned for my next video. Bye bye.